For time restriction in the nucleus, type 1. Type 1 has three different units and modification and specificity or restriction. Therefore, multifunctional enzyme with the restriction methylates and ATP activity. Type 2. These enzymes do produce secret restriction fragment and distinct gel binding partners, and they are the only class used in the laboratory for routine DNA analysis and gene cloning. Type 3. These enzymes require two sequences in opposite orientation within the same DNA to accomplish cleavage, but they rarely give complete digest. Type 4. Recognize modified DNA. Unlike methylate DNA, they code DNA outside of the target sequences and they are variable in their complexity and requirements. There are several things that should be considered when using restriction enzymes. Some for other same pH, magnesium, salt concentration, BCI, glycerol, incubation temperature, and volume.
In the gel, the first thing that was loaded was the pair base marker, and then the unrestricted plasmid. Then the first enzyme was added to the plasmid. In the third lane, there's the second enzyme with the plasmid. And finally, in the last lane, there's the restriction made with both enzymes. This was repeated for each theme from 1 to 4, in this case because the results from teams 5 and 6 were not saved. In all teams except for team 3, there can be observed the degradation of the sample, and they can also be observed some distortion in the bands formed. That's due to a high quantity of sample that was loaded.
In this laboratory practice, we made a cut in our plasmid with restriction enzymes. We use SHO1 and SCA1, but the results weren't clear, so we used the results of the third group, and they use SCA1 and ENCO1, but the results of the ENCO1 weren't clear because we kind of think that maybe it had star activity, or it could be contaminated because you can see in the third row in the electrophoresis that there were some unexpected cuts, so that's why we know this wasn't working. And in the second lane, we can see that the SHO1 did work well.
Vector necessary to have the DNA sequences of there. There are several programs that use the registration map like SNAPGIP, one current by New England Biolabs. Will we use this example? First, the DNA sequence mode they introduce in the space designed to enter the DNA sequence or the gene bank number. It is necessary to specify in the sequences linear or circular. When the sequence is submitted and the map of the vector will create. It is necessary to choose the enzymes that will be used for digestion in the custom digest option. After selecting the digest button, be select. After selecting the digest button, only the select enzyme will appear in the map.
Enzymatic digestions performed did not work as expected because when we used only one enzyme to cut, we expected just one band to be formed, although we can observe more than one. And when we used both enzymes, we expected only to be formed two bands, and we can clearly see more than two. This is due to maybe the amount of sample that we used or the amount of enzyme, and maybe it's experiencing some star activity that it's making on specific cuts in the wrong places of our plasmid, so that can explain the different bands we got in the gel. The conclusion, we must know how to calculate the width of the bands we want to get when we do a restriction enzyme with enzymes, because that will let us know how well did the enzymes are working, and we can interpret that results by reading the gel. If we do not know how to calculate it in silico, when we do it in vivo, it won't have any impact in our study.
With our results, we can conclude something because it wasn't clear, analyzing all the parameters to consider in order to obtain the best results with our restriction enzymes. We should start thinking about the concentration of the enzyme or some contamination because we can observe some in a specific cut with NQ1. It should be caused because of an excess of glycerol which could cause star activity in the enzyme, but also contamination which could interfere with the enzyme and cause in a specific cuts. We could observe that we have many troubles in the protocol even if we are not analyzing all the parameters to be careful about during a digestion. Sometimes you need to do a double digestion, and in these cases you need to be very careful with the temperatures of each enzyme in order to give each one their activity time but also their inactivity time. In conclusion, we need to be very careful with the correct function of our enzymes. First, verifying their activity, but also taking care with the concentration of the enzyme, the quantity and quality of the DNA, and the temperature for each enzyme, because many of them interfere in our results where we obtain specific cuts with our enzymes.